Hello, in this video I will provide some examples of analysis problems that you can encounter when analyzing your experiments, and also some examples of methods or strategies that can be used to overcome these problems or to minimize the impact of this problem in the analysis. So I will quickly try to run through different problems and then potential solutions on the coming slides. The first problem you may encounter is that you have an active contrast that can be due to several possible interactions or a main effect, for example. So how can you solve this problem? Well, you can, first of all, you can try to run a complete fold over um, like this. So you add the missing points here in this cube, for example. Now this is recommended only for resolution 3 designs. Because the complete fold over will increase the resolution from 3 to 4 in these cases. Another alternative that you can use is to run some sort of incomplete fold over, such as, for example, an optimal fold over, adding maybe 1 or 2 extra points only. The resulting design, however, will be non-orthogonal and unbalanced most of the times. So you will end up with some tricky allies pattern for the remaining effects then, but still you will be able to differentiate between the competing interactions for this contrast. Another problem that you may encounter is that you have active factors that you have found, factors in terms of either main effects or interactions, but we're still far away from the optimum. Now, to try to solve this problem, we need to move the experimental region uh, closer to the optimum area somehow. And we need to do that by changing the levels of the factors, of the active factors especially. And there is a method for this also that we can use in terms of the methods of steepest ascent or descent, depending on we're trying to maximize or minimize the response. But we want to move the experimental region somewhere closer to the optimum area, if possible. Another problem that we may encounter is that we have too high variability to be able to draw conclusions about active effects and interactions. Now, if we can afford and if it's possible for us to add replicates to the design, uh, like this, for example, we will increase the analysis power for a given signal-to-noise ratio. Now, of course, this will cost resources or money, but still, it's one way to be able to draw conclusions is by increasing the analysis power. Okay. Another problem that we might have is that we have, uh, before the analysis at least, a likely effect that we find insignificant in the analysis, and this is unexpected. Now, what we can do to solve this issue is to change the levels, maybe to something like this. And why is that a potential solution? Well, potentially because the difference between the factor levels was too small or too big in the original design to be able to detect the effect through the noise. So that's one way forward, is to change the levels. Another problem is that we may start with factors that we believe should affect the response, and in the analysis we find them all to be insignificant. First of all, this may not be a problem. It may be an important result by itself to find that some of the factors that we believe in are not, or maybe all of them, we're not able to find them to be significant. So that might be information that we can use to the advantage, to our advantage after the analysis. But if we're trying to impact the response or move the response in a favorable direction to us, then we may need to consider other factors that may impact this response. So we may have to change design factors also. Another problem we may have is that the response in the design varies a lot. So for example, we can approach a scenario where we have the largest response value in the design is more or less or more than 10 times the smallest value. And this is usually evidence that a transformation of the response is needed. And to look at this, let's check out example 6.3 in Montgomery's course book. And this is a design where we have 4 factors in 16 runs, so it's a 2 to the 4 design. And we have a response that's called advance rate. And if we look at run 16 here, we have 16.3 as a response value here. And in the first design run, we have 1.68. So the difference between the largest and the smallest response value is approximately 10 times. Or the largest value is approximately 10 times larger than the smallest value. So this should mean that there might be a need for a transformation. Now, just take a look at some plots from this example. So here you have the original response. We find 1, 2, 3, 4, 5 potentially active factors here in the half normal plot: flow rate, rotational speed, and type of mud. Now, if we follow and make some recommended transformations here, we can use the log transformation. I will show you some plots later on also to motivate this. But if we use the log transform response when we try to pick out active effects in the half normal plot, we will only have B, C, and D as active effects. So the situation in terms of number of active effects have also become a little bit easier for us in the log transform response. And this can be motivated looking, for example, at the normal plot of the residuals, where the normal plot for the first model in the original response, we have some deviating points, this one and this one, from the normal probability plot, while the log transform response, the model from that response, is much more seems much more normally distributed. Another potential plot where you can see a potential need for a transformation of the original response is this one where you have residuals versus predicted, and we can see that there is almost a funnel shape for the residuals from the model with the original response. We have one really big deviating residual, and this is also quite big. While from the model for the log transform response, we have sort of eliminated this funnel shape, and we have some sort of stable variability in the residuals. So that's an example of a situation where the a transformation of the response may solve some of the problems that you have in the analysis. Another problem you may encounter is that many design runs gives a 0 response value. Now, this is a difficult situation, and in these cases, then the response is not well designed. So you may need to pick another response and run the experiment again, unfortunately. So we do what we can to try to avoid getting into a situation like this. It's quite common to have some design runs with missing data. Now, having single missing data or single missing response values actually is not a big problem, and it has been shown also in your course book in example 10.3 in Montgomery. Now, and also if the missing data are limited to one or a few data points, and we have at least such a big design that we have potential higher order interaction effects that are unlikely to be active. So if we're in this case, we have 3 or 4 factor interactions that we, at least without too much risk, can assume that these effects are insignificant and should be zero. So if we can make that assumption that these a certain number of the interaction effects can be set to zero, then the unknown and missing response values can be solved from these equation systems that we can get from these assumptions, so that we can set response values, missing response values, to a value that gives the zero interaction effects that we have assumed. Now, that might be a possible solution to actually get response values to put into the design. But we may also have situations where we have response values that are missing from a certain factor setting or combination consistently in the design. And if that's the case, then these design runs, or perhaps even the entire experimental design, needs to be run again. But if you have only one or a few missing data runs, you can use the first two bullets here, either to ignore it or to try to fill these data points using this method. Okay, this is a fairly common situation as well, or a problem, that one design run gives a very strange response value, or at least it's strange compared to the other response values we have. Now, in these cases, it's good to go back to the experimental nodes and try to see if there are something in the notes that can explain this behavior. If there is some evidence that there was something strange going on during this design run, well, what we can do is to run the design run again, and or remove the response observation from the design. Then we can have some evidence that this deviating response value is actually faulty and should be removed. But if we have no evidence that something strange happened during this design run, then we should either keep this response in the design and analyze it with this design run or response variable included, or we can run the design again and see and see if this strange response value will be maintained also in this replicated design point. All right. Another common situation is that you may find both unlikely and many interaction effects to be significant in the analysis. And as we saw also in this example 6.3, that might also be a case where after a transformation, the situation and the number of active effects and interactions are reduced after the transformation. So this might be first potentially evidence of that a transformation is needed. But it may also be evidence that the underlying true response surface may be highly non-linear. We may, for example, be close to an optimum, or we may be in an area of the response or the underlying response surface where a linear model with interaction effects only may provide a poor approximation of this true underlying surface. So in cases where we get many active interaction effects in our models, these two potential explanations should be considered, either transforming the response, or we may need a more complicated method, such as a second order model, for example. All right, so in summary for this video, there are a number of common problems that you can encounter when you're analyzing your experiments. And this video, I've only highlighted a few common examples of problems. There are other problems as well, of course. But you should also know that there are several methods and strategies that we can use to overcome these problems, to analyze the experiment and to draw conclusions, even if we have problems like the ones I have all just talked about. And with that, I would like to stop this video and thank you all for listening. Bye bye.